Welcome to The Explainer. Today, we're diving into a pretty wild idea, something straight from the cutting edge of AI research. What if a simple picture wasn't just a picture? What if it could secretly be an executable program?
All right, let's get right into it. It all starts with a question that seems pretty simple on the surface, but it really makes you think about the AI we use every single day. Why was there such a massive push for image generators before, well, anything else? The source material we're digging into today suggests that might not have been an accident at all.
So from this point of view, all those early, sometimes kind of goofy AI images, they were way more than just fun little experiments. They were actually a way to train these models to find a much, much deeper meaning in pixels, to create a hidden language that goes way beyond just, identifying a cat with a guitar.
So how on earth would that even work? How can you hide instructions inside an image? Well, it all starts with a concept that's surprisingly straightforward, just a simple grid of colored blocks.
Okay, so try to imagine looking at an image, not as a picture of something, but more like a flowchart. Each tiny piece, every little 5 by 5 block of pixels, isn't part of a bigger scene. No, instead, it's a specific, individual command that tells an AI exactly what to do next.
And what's really fascinating here is just how simple the whole decoding process is. It's basically 3 steps. First, the AI finds a specific block of pixels. Then, it just reads the average color of that block. And finally, it matches that color to a command that's already been defined, kind of like looking a word up in a dictionary. It's the key that unlocks all the instructions hidden in plain sight.
And here you go. This is basically the dictionary. Think of it as the Rosetta Stone for this new visual language. You can see right here how each color is mapped to a very specific command. Red means stop, green means go, yellow means wait, and so on. Every single color has a crystal clear, unambiguous command, creating this universal, machine-readable logic.
So let's take this to the next level. Let's see how this whole thing builds from just a few simple commands into a full-blown executable program. We're talking about going from a single word to a complete sentence, maybe even an entire story. So here's the really crucial point. The image stops being just data for an AI to look at. It actually becomes a self-contained application. A bit like a Docker container if you're familiar with software development. It holds all the rules, all the logic, all the instructions needed for a specific task, just sitting there, dormant, until it's called on to run.
Now, to make all this happen, you'd need a totally new kind of system. The source material calls it a Visual Logic Engine, or VLE for short, and its whole job is different from a normal image model. It's not built to see the picture, it's built to read the program that's hidden inside it.
And this right here brings us to the most fundamental difference between this tech and the AI we're all getting used to. We're talking about a completely different paradigm. You see, large language models are incredible prediction machines, right? They're designed to guess the most probable next word. But a VLE doesn't guess, it knows. It follows a set of clear, deterministic instructions that are laid out in the pixels. It's really the difference between jazz improvisation and reading sheet music.
This idea is so new that the source material actually gives it a name, VisLangOps. It's a hybrid. It's not just vision and it's not just language. It's a bridge that connects the two, and it's what turns a static image into a dynamic, executable action.
But of course, with any technology this powerful, there's always a flip side. The very thing that makes this so innovative, hiding logic inside a picture, is also what makes it potentially, well, pretty dangerous. I mean, think about it. All of our current AI safety systems, they're built to analyze text, to look at prompts. But if the instructions are encoded in pixels, they could just slip right past all of those filters. It's a command language that's completely invisible to a human moderator, which would make it incredibly difficult to trace an AI's intent back to its source. But okay, before we get too carried away with all the doom and gloom, the source material is really clear about this. The goal here is not to build some kind of undetectable malware. The real purpose is actually much more constructive. It's about building a better, more understandable, and more intentional artificial intelligence.
So, let's explore that positive side for a minute. How could this visual programming language totally revolutionize the way we teach our machines?
This quote right here really gets to the heart of it. The idea is to move away from AI that just makes statistically good guesses and move towards an AI that truly understands and acts on clear, structured intent. It's really about teaching purpose.
So, by feeding an AI images that contain entire scenarios, complete with rules, actions, and consequences, we could teach it to simulate, to plan, and to comprehend the world in a totally new way. And this could lead to models that aren't just more capable, but also more explainable, because their thinking is based on a clear, visual logic that we can actually follow.
Now, this technology is still very, very much in its infancy, but it opens up a future that is both fascinating and incredibly powerful. A future where AI agency isn't just something that sort of emerges from training on huge data sets, but something that could be programmed directly into the visual fabric of our digital world, just waiting for the right moment to be executed. It's a wild idea to think about, isn't it?